Hello again. In the previous lesson, we solved trigonometric equations. In this lesson, we will use trigonometry in applications. Okay, so what we're going to do is we'll use right triangle trig, angle evaluation, and uh, what is called sinusoidal models. Okay, very hard word to say. Sinusoidal models. Okay. And a lot of people pronounce it differently, but let's begin with the quick rules. So, right triangle trig, first of all, right triangle trig, we have sine theta equals opposite over hypotenuse, cosine theta equals adjacent over the hypotenuse, and tan theta equal to the opposite over the adjacent. Okay, so the angle of elevation is measured upward from horizontal. Okay, sinusoidal model is y equals a times sine parentheses b x minus h plus k, and you should remember that from the expression should feel very similar to you because we see a shift in the x and we also see a shift in the y, or this is essentially y is equal to a times cosine parentheses b parentheses x minus h plus k. Okay, the amplitude stays the same, so the absolute value of a. Period is 2 pi over absolute value of b, and then the midline is y is equal to k. Okay, midline is y is equal to k. Okay, let's first of all look at example number 1. So a ladder is 18 feet long and makes a 68-degree angle from the ground. Find the height the ladder reaches on the wall. Okay, so the ladder is the hypotenuse because it's the longest side, right? So imagine a wall here, and then imagine a ladder up against that wall. Okay, the ladder would be the hypotenuse, right? Okay, the ladder is the hypotenuse because it is the longest side and it leans against the wall. The height on the wall is opposite the 60-degree angle, right? Because the ladder is 18 feet long and makes a 60-degree angle from the ground. So this angle right here that it makes from the ground, excuse me, this direction, 68 degrees. Okay. So we have opposite and hypotenuse. That means we use sine. Okay. So sine theta is opposite over the hypotenuse. So what we would do is substitute the values. So we have sine theta, or the sine of 8 degrees, right? Because we know the angle, right? The angle would be the theta, and then the opposite would be h over 8. Know the hypotenuse. The hypotenuse would be 18 feet. Okay, 18 feet and degrees. Okay, and I should probably put wall here. Okay, now what we can do is we can multiply 18 to both sides. Okay, so I'm going to move over here. 18 times sine 68 degrees equal to h, and that comes from me multiplying both sides by 18. Okay. So by multiplying by 18 to both sides, I get the height. Okay. And I can compute this with a calculator. 18 times the sine at 68 degrees is going to give me a height of approximately 16.7. So the answer is about 16.7 feet. Okay. Okay. Find the height. The ladder reaches the wall. Okay. So the wall at about right here would be about 6 feet. Okay. Example number 2. A person standing 120 feet from a building sees the top at an angle of elevation of 35 degrees. Find the height of the building. So the angle of elevation is measured by the horizontal line upward, and the distance from the person to the building is 120 feet, right? That is the adjacent side, because this is the building, and then the person at 120 feet from the building. Okay. So the person is standing 120 feet from the building. That is the adjacent side. So the building height is opposite the angle. All right. As a matter of fact, it says the person standing from the building sees the top angle, sees the top at an angle of elevation of 35 degrees. So let's just say their vision, okay, the vision cast from them, right? 35 degrees. Okay. So again, that is the adjacent side. So the building height is opposite the angle, right? Building height would be opposite. So that is tan theta. So just for the record, the building height is opposite the angle. So we have the opposite and the adjacent. Okay. So the opposite and the adjacent is what tan is. We can substitute the values. We have tan at 35 degrees, which equals opposite. The opposite is height. We don't know that yet, but we do have the adjacent. Or excuse me, we do have the adjacent, which is 120. Okay. Multiplying both sides by 120. So that's 120 times of 35 degrees. That will give us H. H is approximately, let's see, 84. Okay. So the answer is height is approximately 84 feet off the ground. Okay. Or 84 feet tall. Is another way to say it. Okay. All right. Pause and try the problem below. A flagpole casts a 42-foot shadow. The angle of elevation to the top is 51 degrees. Find the height. Okay. So the shadow is along the ground. So it is the adjacent side. Okay. So just imagine um, so we have the flag, the shadow it casts. Okay. So we have the adjacent side. The height of the flagpole is the opposite side. So we have the opposite and the adjacent. So we're going to use the tangent. Okay. So the way that would look is we have the angle of elevation to the top is 51 degrees. So that would be 10 degrees. And the flagpole has a 42-foot shadow. Okay. That 42-foot shadow would be the adjacent. Don't have the height yet. Maybe we don't have the opposite. Right. Okay. Now, from there, what we would do is we would calculate it by multiplying 42 to both sides. Using a calculator to compute that, that would be h is approximately 59. Okay. That would be 51.9. So the flagpole is about 51.9 feet tall. Let's continue. Example number 3. For ht equals 4 times the sine parentheses pi over 6 multiplied by t minus 3 plus 10. State the amplitude, period, phase shift, and midline. Okay. So this is a sinusoidal model. Compare it with the form y equals a sine x minus a plus k. Okay, so essentially we're comparing that with this right here. Sine b would be pi over 6 parentheses minus b plus 10. Okay, so if we were comparing it, we would line it up perfectly like that. So now we need to identify each part. Okay, so the coefficient outside of sine is 4. So the amplitude is 4. Amplitude. Okay. The b value would be pi over 6. So what we would do is use the period formula. Okay, so if you recall, the period formula is 2 pi over the absolute value of b, pi over the absolute value of pi over 6. And what we would have to do is divide by pi over 6, or in other words, multiply by 6 over pi. So 2 pi times over pi. So that would be 12 as the final answer. So period would be 12. Okay. Now we need to identify the phase shift. Inside the sine function, we have t minus 3. So the shift is right 3 units. Okay. And then finally, we have plus 10, which gives us the midline, because remember, the midline is y equals k. So in our respect, the plus 10 would give the midline. So y be equal to 10. So those are the final answers we have. The amplified would be 4, period would be 12, the shift would be 3 to the right, and then the midline would be y is equal to 10. A Ferris wheel, this is example number 4. A Ferris wheel has a maximum height of 80 feet and a minimum height of 20 feet. One rotation takes 30 seconds. Find cosine model starting at the maximum height. So we're asked to find the cosine model. Since the model starts at the max height, cosine is a good choice, right? Because cosine starts at the 1 or at the peak. Because the maximum cosine is, or excuse me, the basic cosine starts at the maximum. So we need to start with the amplitude, okay? So the amplitude is equal to the max minus the minimum divided by 2. So that's essentially 80 minus 20 divided by 2, also 30, okay? So the amplitude is equal to 30, right? Because there's a max of 80 and a minimum of 20. So again, just think about the max being here, the minimum would be here. The rotation takes place like this because it's a Ferris wheel. The max would be here, the min would be here. So in order to understand the magnitude, you would have to take the distance of that, okay, and divide it by 2. Now we find the midline. So the midline is the average of the max and the min. So the max plus the min divided by 2. That's 80 plus 20 divided by 2, 50. The midline equals 50. The period is the time for one full rotation. Okay. So that one full rotation is 30, right? Because one rotation takes 30 seconds. So the period is equal to 30, or 30 seconds, I should say. We can use the period formula. So the way this would look is we would have 2 pi over the absolute value of b equaling 30, right? Because it says one rotation takes 30 seconds. That would be the period. So if the period is equal to that, we can set 30 seconds equal to p because we know that p is equal to this. Okay. Then we can solve for b. So what we need to do is, first of all, we need to multiply by, let me see, I want to get the, how do I want to do this? I'm going to multiply the, I need to move this over because I'm running out of space. Let me do this. I'm going to multiply the absolute value of b to both sides first. And then that would give me 2 pi equals 30 in the absolute value of. Then I'm going to divide 30 to both sides. So that's 2 pi over 30, which equals absolute value of b. And I should have simplified that. That would be simplified to pi over 15. Pi over 15 is equal to the absolute value. And so we could use b as the absolute value of 15. Since the wheel starts at the max height, we're going to use the cosine with a positive amplitude. Okay. Uh, I, I essentially ran out of space here, but I'm going to see if I could get this in. So b is equal to pi over 15. Okay, so what we need to do is, as a matter of fact, I'm going to go down here to the common and just use up some of this space down here. Let me see if I can get both of them on the screen. Okay, so essentially what we have here is height, and we have 30, right? So we have Ferris wheel has a max height of 30. So again, the amplitude would be 30, right? Then we would have a cosine function, right? It says write a cosine model. This would be cosine, then parentheses, and then we have b, right, which would be pi over 50, and that would be multiplied by t in terms of time, right? Because um, the b would be what, like it says, one rotation takes 30 seconds, so that's essentially what's happening. Every 30 seconds, it will be multiplied by this right here, plus 50, the midline. Right? Now, let's check the model at t is equal to 0. Okay, so if we check this model for t is equal to 0, we would have h0 equals 30 cosine of 0, essentially, right? Because 0 times anything is 0, plus 50. That would be, remember, cosine at 0 is 1, and that would be 80. So height at 0 would be 80. And guess what that matches? That matches the maximum height. So this model makes perfect sense. Okay. Now, the common mistake problem, a student uses sign when the problem gives opposites and adjacents. Correct the ratio choice. So the mistake is basically choosing a trig ratio without checking the sides. Sine uses opposite and hypotenuse. The cosine theta uses the adjacent over the hypotenuse. And then the tan theta uses the opposite over adjacent. All right, some people used to say, so uh SOA. That's just a way to remember these. So SOHCAHTOA, SOHCAHTOA. Okay, just to remember the ratios for those things. So if the problem gives the opposite and adjacent sides, right, the correct ratio is tangent, not sine. Okay, so always choose the trig ratio based on the sides that you have and the side that you need. Okay, so the final review. So the main thing is to understand what we just went over, which is SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent. Okay, so the right triangle trigs uses sine, cosine, and tangent ratios. Angles of elevation is measured upward from horizontal. This model is very easy to understand. We only had one problem here, but the more you practice it, the better and more proficient you'll get at it. And then these things are your best friends because these make your life a whole lot easier when you're interpreting these. And if you like my drawings, make sure when you have these application problems, it's best to maybe sketch it out so that you can kind of understand it and visualize it as you're working it out. All right. So with that, thank you for watching, and I'll see you in the next one.